When you look at the drugs here from table 10.4, you look at the different drugs and you begin to see which drugs, we split them up into different classes and different groups, the penicillins, the cephalosporins. We subdivide, we divide them up by their target, cell wall, protein synthesis, things like that. And then we go through and we can also divide them by their generations. You look at penicillin. The original penicillin that was isolated and used, back in the 1940s, was no longer in use. The microbes have become resistant to it. So what we've done is we've taken, as we're going to talk later in this chapter, we've taken penicillin in the laboratory and we've modified it. We've either modified, the microbes that are producing it for us to give us slightly different variations of penicillin, or in a test tube, or a vat, we've come up with ways to chemically alter, chemically do things. So when you look at the penicillins, you'll notice that whole group, everything ends in -ilin. So if it ends in -ilin, it's a derivative of penicillin. So they can go through and they can say, penicillin G, penicillin V, ampicillin, amoxicillin. These are all derivatives of penicillin, and every time they come up with a new iteration, a new drug that's based on a previous drug, which is based on a previous drug, they call these generations. 4th generation penicillin, 5th generation penicillin. The cephalosporins, same thing. Original drug was probably something that we isolated from a microbe, a bacteria, a fungi. And then we went through and just, once it was no longer working or it wasn't feasible, because, the only way to get it was to grow up a big vat of, with cephalosporins. The original one, the 1st generation, was cefazolin, which worked great. But 1st generation, gram-positive good, gram-negatives not so much. And it doesn't take long for those gram-positives to start becoming resistant. So then you have to take the cefazolin, twist, tweak, modify it, 2nd generation, 3rd generation. Now with these different generations, you can also narrow the spectrum or broaden it, get it to target, or just be, like I said, the sledgehammer. And then you look at the drugs to do the protein synthesis, folic acid synthesis. Talked about the folic acid synthesis. This is one of the original sulfa drugs. Sulfa drugs, if I remember correctly, came out just before World War II, was used throughout World War II. I'd have to go back, can't remember if it's World War II, World War I. This inhibits folic acid synthesis. The sulfa drug mimics, it closely resembles one of the intermediate substrates in the pathway. So it's a competitive inhibitor for the pathway. So it doesn't completely get rid of folic acid synthesis, it just turns it way down. The higher the concentration of the sulfa drug present, the less folic acid can be made, and it gets to a point where the bacterial cell is starved for folic acid, which means it can't make new nucleotides, can't replace certain things, and the cell dies.